Hi all, welcome to the first part of the video lecture on Relational Data Model. So this is the second module of your database management system course. So this is the starting topic, and see recollect what you gone through in the first module. So where we gone through the basics of the database, right? So what is database, what is database management system, so like that the basic concepts we studied, and also we saw that popular conceptual model, right? So this model, so model, how to draw this model from a given set of requirements from the user is what we seen in detail in our first module. Okay, so model is a conceptual model. Okay, data model, conceptual data model. Now it's time for us to explore the next level, that is the implementation or the representational data model, right? Representational or the logical data model, representational data model, and that is our relational model. Okay, so we will see this model in detail here, and also another following the basics of this relational model, we will see how this model can be mapped to a relational model. Okay, so that is the flow, and finally we will go for the actual design. So now relational model, it was first introduced by this person Ted Code. So he's an IBM researcher in 1970. So in a classic paper called Code 1970, so you can refer this his research paper also on this relational model, and it is attracted immediate attention due to its simplicity and mathematical foundations. That's very important. Why relational model? This is one of the representational data model, just like model is a popular form of conceptual data model modeling technique. This relational model is a popular form of representational, I mean the next level, intermediate level data modeling technique. Okay, so why it is popular? So along with the relational model, there are many other data models proposed by people, but out of them this become the dominating one. It is because of the mathematical foundation this model is having. Okay, so and also it's a very simple to understand model, so that makes it a popular one. Okay, so the model uses a concepts of mathematical relation. What is a relation in discrete mathematics? Relation is a subset of the Cartesian product. So when I'm defining a relation, say from a set A to another set B, basically you can see that this relation is any subset of this Cartesian product A cross B, right? So it is of the form something like ordered pair x y, such that some relationship we will establish. So something like this. So the same concept we are applying here also, but we will see how this concept we will see the formal definition of this relation in relational data model, and we will see how this can be applied here. Okay, it looks congested. So which looks somewhat like a table of values as its basic building block, and has its theoretical basis in set theory and first order predicate logic. Okay, we will see that. The first commercial implementation of the relational model became available in 1980, and it is this SQL bar DS system on MVS operating system. So these are all the historical background. You can see more detail about them if you are interested, but we are not going to concentrate all those things. We will study this relational model followed by that mapping, then we will focus more on this SQL alone. Okay, and once you have a strong base on just like programming language you are studying, that C programming, with that you will get a feel of it, right? So similarly SQL we will study in detail, but later on if you want you can switch to whatever backend you want. So when you are in doing your web application developments, that time you will experiment different relational data models, of course. Okay, so that about it. And so this MVS operating system by IBM and Oracle DBMS. So these are two situations where the relational model started using. Since then, the model has been implemented in a large number of commercial systems as well as a number of open source systems. So some of the implementations are like this. So the current popular commercial RDBMS. Okay, so we call it as RDBMS, Relational Database Management System. So that is RDBMS. So we will be using this short form throughout. And some of the popular implementation of this RDBMS are like DB2. So this is from Oracle, IBM and Oracle from Oracle itself. Then Sybase DBMS from this organization called SAP, SQL Server, and Microsoft Access, of course, from Microsoft. Okay. Yeah, so this MySQL and PostgreSQL, these are all two open source implementations of it, and you will be seeing these things in detail in your next semester maybe in database management system lab, okay, laboratory session. The relational data model, so if you are looking at formal languages are associated with the relational model, right? So what I was trying to say is, basically it is a model, right? So we need a language to implement it. So language itself you can think of like a SQL language, which is something used by the programmers, or you can think of a formal language for it. Okay, so formal language in the sense it's not a practical one, but it gives a strong theoretical formulation for the same. So once you know about it in detail, it is easy for you to switch into a practical language. So we have both of them. Like SQL, if you are looking at it, it is a practical implementation of this relational database management system, where this relational algebra and relational calculus are two formal languages associated with the relational data model, and that also makes this relational data model much popular, because a model is now coming with the two formal languages also. So when that code proposed this concept, he proposed this relational algebra and relational calculus also along with the model. So how we can interact with the model, so that is being formally explained by this relational algebra as well as relational calculus, and out of them I think relational algebra is there in your syllabus, calculus is not there, I hope so. So whatever is there in the syllabus I'll be covering. Now if you're looking at SQL, it's a practical thing, right? It's a practical implementation. So it's a comprehensive model again and language that is the standard for the commercial relational DBMS. So when you try to implement this relational DBMS software commercially, you can opt a model or a standard provided by SQL, okay? And SQL is the basic one, and we can see other variations of it also. The relational calculus is considered to be the basis of the SQL language, and relational algebra is used in. So anyway, these things are in detail about those things. Anyway, I think relational algebra we will see in detail. Other one, if it is there, we will see. Otherwise, you can read from the textbook. So that about it. They are two formal languages by which we can communicate with the relational model. Okay. Conceptual schema in ER or EER. I mean, ER, hope you remember, entity relationship model, or extended ER, entity relation model, are to be mapped into the relational representations. That also we will see how this mapping can be done. Now there are something called open database connector, something Java database connector. So these are all standard protocols or the programming languages to relational database connectivity. Okay, so they are being used by programming languages to get connected with the relational database, and how this connection can be established on those things you will see when you have the laboratory course. Now the some more concepts about it. In the relational model represents database as a collection of relation. Okay, you can see each in the database system, each individual database is represented by some kind of a table structure. So typically relation is having a table structure, and the meaning is the normal mathematical meaning of relation is what is applied here also, and how this is related with the table structure we will see. Informally, each relation resembles the table of values and to some extent, and some flat file of records also you can see, because if you are looking at a table, information is stored in as different rows, right? And each row corresponds to a record of related information, and together we can keep it in the secondary memory as a flat file of records. So it is called a flat file because each record is simply a linear or a flat structure it is following. If for example, if it is a student database, you can see that the first record may corresponds to the first student, okay, maybe what is his row or her roll number, name, address, CGPA, those information. So it looks like a linear flat structure, and together one after another we can store the record in a file. Even though you are visualizing it as a table or a relation, on background it is represented like a file only. When a relation is thought of as a table of values, each row in the table represents a collection of related data values. So this is important. If you are looking at a particular row, we will see example, and for example, the student relation, a row corresponds to details of a particular student. So they are related in such a way that all of them corresponds to a given student. Now a row represents a fact that typically corresponds to a real world entity or relationship. So it can corresponds to an entity or a relation. So this also we will see how these entities are getting mapped to relation or rows of information, and relationships are also sometimes converted to relations or tables or rows of information. So basically each row corresponds to some real world entity or relationship. Okay, we will see that the table name and column names are used to help to interpret the meaning of the values in each row. And if you are looking at each relation, so we have a name for the entire relation or the table. Okay, and each columns also having some column name, and that interpret what does it mean. So what this particular table corresponds to, say it corresponds to the informations of students, so then I can call it by a name student, like that. Similarly each column header corresponds to different attributes of that particular entity or relation. Okay, so in the former relational model terminology, a row is known to be, so this is another terminology, you can keep this in mind. So tuple is nothing but a row, a particular, if you are looking it as a table, say student information, you can see. So so here you will have this what called a column name, right, like a student name, say student roll number, say CGPA, like that you can store anything. So these are all the column names, and now you will store the details of the first student, say with the name, some something, some roll number, like that. So this row is what we call as a tuple. Okay, you can see, so that is a terminology. Okay, now the column header, like the student name or the student roll number, these things are nothing but the attributes, right? So if you are looking at entity, these are all the entity attributes. Now they become the column headers of the relation. And the table as a whole, so this table will be having a name also, say let me call it as a student table. Okay, and the whole thing, this table is also called as a relation. Okay, and this term is having the same meaning as that of I mean the meaning you are giving in discrete mathematics. Domain of an attribute. Okay, so that about it. Now you can visualize a table having a set of rows and column headers are the attributes, and rows are otherwise called a tuple. Now if you are looking at each attribute, you know, the set of all possible values for an attribute is what we call as a domain. Same terminology we saw in ER model also, same meaning here also. So domain or D is the set of atomic, so it's basically it is atomic, right? So you can't divide it further, and variations are also there, but in basically in relational model we talk about atomic set of atomic values as a domain. A common method of specifying a domain is to specify what is its data type, okay, and from which the data values are coming. So if I'm saying that its domain is integer, is the data type, then I can say that the domain is something like set of all integers. Further you can have restrictions also. So it is also useful to specify a name for the domain. If you want, you can give some meaningful names for the domain. For example, USA phone number. So this is a name I am given to a particular domains that represents the phone numbers of the citizens of USA, right? So it is a, I can define also. So this corresponds to set of all 10-digit phone numbers which are valid in US. Then you may heard the social security number, some kind of identification. The set of valued say 9-digit social security numbers which are unique identifier assigned to each person in United States for the employment, tax and other benefits purposes. Okay, so this is something used in US. So for employment, tax and other benefit related purposes, he can make use of this unique ID. Name, the set of character strings, of course, right, that represents the name of a person or a student, whatever it is. The preceding is called the logical. So something like this is what we call as a logical definition of the domain. And so here you can't precisely say what is the data type. So along with this logical definition or the meaning, there is a data type or a format also associated with the domain, right? For example, the data type for the domain USA phone number can be something of the form, right? So it's something like some 10-digit information, right? Some 3-digit followed by 7-digit, where each D corresponds to a numeric or the decimal value, and together this is how you are representing. And why this first 3 digits are put like this, because they correspond to the area code. Okay, you know the structure of a typical phone number, right? Now there is some terminology like what is schema. Okay, so these things we saw in ER modeling also. There we have the entity schema, like that. So here it is relation schema. A schema basically means a structure, right? So a relational schema R is typically denoted by R of A1, A2, etc. AN. So you can guess like, so this A1, A2, etc. AN, they are all the attributes and R is the name of the relation, that's all. So it is made up of a relation, say with the name R and list of attributes A1 to AN. Okay, so each attribute AI is the name of a role played by some domain. So if you are looking at so corresponding to each attribute there is a domain, or attribute is nothing but the role name of the domain. So you can interpret. So here this is a role name of this particular domain, right? So you can represent it by an attribute like that. Or for each attribute there is a corresponding domain, and D is called the domain of AF, and this is how you can represent a domain of the attribute AI. So in a relational schema, this R, that is name of the relation, is called a name. Oh yeah, the R is called the name of the relation, and typically you can associate something called as degree or arity of a relation, that is a number of attributes in it. Okay, for example, if you are having this student relation, say these are all the attributes: name of the student, right? Social security number, home phone number of that particular student, address information, office phone number, okay, age, and GPA. So there are 7 attributes here, right? So you can think of it like a relation with the degree 7. So I can say that here degree of this particular student relation is 7. Okay, using the data type for each attribute, the definition someday. So if you want, you can define like this also, right? So this is more meaningful, right? And what I'm saying is name is of type string, social security number is of type string, home phone number string again, address string again, so all are here string. So here you have this real value and integer value. So this way also you can define. Okay, so this is how you are defining schema of a relation, name of the relation followed by name of all the attributes, or if you want you can specify the data type of the attributes also, so that this will be more meaningful way of defining a relation. So what is relation? Schema, something like this, attributes and their domain. This is what we see. Now similar to schema, you can, entity ER model also, we saw this term also, like a state of the relation, right? At currently what are all the values this particular structure is holding. So a relation or a relation state R of the relation schema, this is a schema. This is how you are denoting a schema. And what about its state? Typically we denote by small r of capital R. Capital R is our structure, schema name, and small r represents the state, current state. So it is typically a set of n tuples, right? So tuple is nothing but the row. Hope you remember, row 1, row 2, etc. Some m number of tuples are there, and each tuple, each ti is an n tuple. So this is what we mean, n tuple, ordered n tuple. Hope you remember. Anyway, this like ordered pair, ordered triple, you can think of ordered n tuple. And what does it mean, we will see in the next video, say where I will formally define a relation. That time I will tell you what is the meaning of this n tuple. Okay, so basically there are m number of tuples or rows, and each row is a n tuple. Okay, some ordered collection of n attribute values. So that is a meaning. So n attributes are there, and each attribute is having a value corresponding to this particular ith row. Okay, so I can visualize ith row as a ordered n tuple having values corresponding to n different attributes. Such m number of tuples will be there in a given relational state. Okay, so this n tuple, and we will see this formally, its meaning in the next video lecture. So it is a ordered list of some n values, right? What is this n? Number of attribute. Each attribute is having a value like v1, v2, etc. N attributes are having some vn number of values, where each value is coming from the domain corresponding to its attribute, right? So ith attribute AI is having a domain from which the ith value is coming. And if there is no value, I can assign something called as null. So where we are using null values represents the attributes whose values are unknown. Sometimes we don't know what is the value. So from the domain, you can't assign because you don't know, right? Or you do not, it may not exist also. Some of the fields are not applicable, something like that, right? So in that case, you can use this null as a value. Otherwise, some value from the domain of the corresponding attribute will be assumed for these VIs. So the ith value of a tuple D. So you look at any tuple for the attribute AI, the corresponding ith value, that is VI, you can denote like a T of AI. So look at the row tuple T, and you can visualize it like an array. So what is the value corresponding to the attribute AI? Or you can also denote it like a T dot AI. Okay, so we will see an example and I will tell you if you have any confusion. So the terms relation intention and extension, hope you remember these terms also. You know, intention corresponds to the structure or the schema, extension corresponds to the state of the relation. So that also we can apply here. So this is a typical example. Here you can see the student relation, and typically this one act as a relation name, and these are all the attributes are nothing but the column headers. Okay, you can see, and these are all the rows or the tuples. And this, say Benjamin Bear, this is a particular value for the attribute name. Similarly, this is another value for the attribute SSN. Okay, so what I was trying to say, okay, that much details are not needed. Okay, you understood what is a tuple, what is a relation name, what is column header or attribute, its values, everything. Okay, what is domain. So that about it. These are all some very basic things from this relational model. Okay, and we will see more into it, its formal definition, of course, in the next video lecture. Yeah, thanks for watching.